Have you ever stopped to think about what keeps you safe? Not just the roof over your head or the laws of your country. I mean something much bigger, something vast, powerful, and completely invisible. It surrounds our entire planet. It stretches far out into the blackness of space. This invisible guardian works tirelessly day and night, protecting every living thing on Earth. Without it, life as we know it simply could not exist. It is a silent, unseen force field, a cosmic shield that we owe our very lives to. We walk through it every day, completely unaware of its constant, life-saving work. This guardian is Earth's magnetic field. The danger we face is not just from our own sun. Space is filled with radiation from countless sources. Beyond our solar system, exploding stars known as supernovae unleash incredible blasts of energy. These cosmic events send high-energy particles, called galactic cosmic rays, hurtling across the universe. They travel at nearly the speed of light. They carry so much energy that they can penetrate deep into matter. This is a constant, universal rain of radiation. It permeates the entire galaxy. Now we arrive at the heart of our story, the magnificent defense mechanism of our planet. When the charged particles from the sun, mostly protons and electrons, encounter Earth's magnetic field, they cannot simply pass straight through it. The magnetic field exerts a powerful force on them, a force that changes their direction. The particles are compelled to follow the magnetic field lines, as if they were traveling on invisible rails. The small fraction of solar particles that are not deflected, but are instead funneled down into the polar regions, create one of the most spectacular natural phenomena on Earth. This is the aurora, also known as the Northern Lights, or Aurora Borealis, and the Southern Lights, or Aurora Australis. The process begins when those channeled solar particles, traveling at high speeds, collide with atoms and molecules in our upper atmosphere. The protection offered by the magnetic field goes far beyond simply stopping our atmosphere from being blown away. It plays a deeper, more fundamental role in creating the stable conditions necessary for life to emerge and evolve over billions of years. Life is fragile. The complex molecules that form the basis of biology, such as DNA and proteins, are easily damaged by high-energy radiation. For centuries, humans have marveled at the incredible navigational abilities of animals. Migratory birds fly thousands of kilometers following the same precise routes year after year. Sea turtles cross entire oceans to return to the exact beach where they were born. Scientists now believe that many of these animals have a secret sense, an internal compass that we humans lack. They can perceive and use the Earth's magnetic field to guide their epic journeys. One of the most profound discoveries about our magnetic field comes not from space, but from deep within the Earth's crust. Rocks, it turns out, have a memory. When molten rock from a volcano erupts and cools, tiny iron-rich mineral grains within the lava act like microscopic compass needles. Their magnetic orientation becomes frozen in place, capturing a permanent snapshot of the field. The geological record shows that the field has completely reversed its polarity hundreds of times throughout history. There is a vast region on Earth where the magnetic field is mysteriously and significantly weaker than anywhere else. This area, known as the South Atlantic Anomaly, or SAA, for spacecraft and astronauts, the SAA is a well-known hazard zone. When a satellite passes through this region, it is bombarded with a more intense dose of high-energy protons. This can disrupt its operations, causing temporary data glitches known as single-event upsets, or even permanent damage to sensitive electronic components. Let's travel back in time to September 1859. The world was a different place. Technology was in its infancy. It was in this era that Earth experienced the most powerful geomagnetic storm ever recorded. This event, now known as the Carrington event, the auroras, normally confined to the polar regions, were seen all over the world. People in Cuba, Hawaii, and even central Mexico reported seeing the sky light up. Telegraph systems went haywire. Operators received electric shocks from their equipment. Telegraph pylons threw sparks, and paper in machines caught fire. Today, we look back at the Carrington event as a stark warning. A storm of that magnitude today would be catastrophic. Our satellite networks, power grids, and sensitive electronics are far more vulnerable than 19th century telegraph wires. For those who travel beyond the thickest parts of Earth's atmosphere, the story of space radiation is much more personal and immediate. As we look to the future, With ambitions of sending humans to Mars, this radiation problem becomes the single greatest challenge. We have journeyed deep into the Earth's core and far out into the cosmos, exploring the invisible shield that makes our world a haven for life. The signs are clear that our shield is not a static, permanent feature. The magnetic poles are wandering at an accelerating pace. The field's overall strength is diminishing. These changes force us to consider what it would be like to live through a period of significant magnetic transition, such as a full field reversal. Imagine a world with several weaker north and south poles scattered across the globe. Our compasses would become useless, and animal navigators that rely on the field would face an unprecedented challenge, potentially disrupting entire ecosystems. The most significant consequence of a weakened and chaotic field would be a dramatic increase in solar and cosmic radiation reaching our planet. This means investing in more robust technology, designing satellites that can withstand a harsher radiation environment, and strengthening our power grids against geomagnetically induced currents. It means continuing our scientific monitoring of the field, using satellites and ground observatories to understand and predict its changes. Let us now engage in a thought experiment, a planetary what if. What if our magnetic shield did not just weaken, but disappeared entirely? Without the magnetosphere to deflect the solar wind, this stream of high-energy particles would slam directly into our upper atmosphere. Our vibrant, living world would slowly transform into a cold, dry, and sterile desert, a ghost of its former self, much like our planetary neighbor Mars. This bleak vision of a shieldless Earth serves as the ultimate reminder of our good fortune. Our journey through the science of the invisible shield is now coming to a close. We have seen how a churning ball of molten iron, thousands of kilometers beneath our feet, generates a force field of immense scale and elegance. This magnetic field stands as a tireless guardian, a silent warrior in a constant battle with the sun, deflecting deadly radiation and channeling its energy into the beautiful, harmless spectacle of the aurora. So, the next time you stand outside under a clear sky, take a moment. Think about the invisible force field stretching from the ground beneath your feet to thousands of kilometers above your head. It is the unseen guardian, the silent hero of Earth's story. And knowing it is there, constantly at work, should fill us with a sense of wonder, gratitude, and profound connection to the incredible planet we are lucky enough to call home.